Unistat 340 PV S35 precision recirculating chiller. It has a digital controller, a cooling capacity at 0 degrees C of 1 kilowatt, a heating capacity of 1.5 to 3.0 kilowatts, a temperature range of between -40 to +200 degrees C, a pumping speed of 20 liters per minute. It is an air-cooled refrigeration compressor. The unit operates on 208 volts AC, single phase, with an 18 amp service. The unit is very easy to use. This is the actual control module. What's nice about this is it snaps out of here and you can put it on a remote cable. Sometimes they will have more than one of these units running in a row, so it's very easy to use. This is the over-temp controller that has been set for 100 degrees C. Again, it has the capacity to go up to 200 degrees C, but for purposes of our demonstrations, we set this here. It's very easy to use. If you wanted to change the temperature, for example, all you have to do is push the button and you could put in a different temperature if you wanted to, or you could escape out of that and put your other one back. You can do the same for the ramping up and the amount of time that you want it takes to achieve a certain temperature. This particular unit has been set for auto load. What auto load will do is after it boots up and it runs through its self-diagnostics, it will automatically start both the circulator and then the refrigeration compressor to achieve whatever your set points are. The actual setup of that for setting it from manual to auto load is well documented in the book here. It's pretty easy to follow. The program directory will tell you all the different programs that you can push to change the different parameters. Actually, this is one of the simpler controllers that I've worked on. Now, it also has the ability to be water cooled. When heating up, things can come very hot, so it does have a heat exchanger in here, and you can use a small chiller to accommodate that. As we can see, this particular one has two thermal hoses that go around and come into, normally this would be connected to your workpiece or your cold head. I have a heavy wall stainless steel adapter in here. As you can see, even well insulated, is crossing through a little bit. The 3 degrees differential in temperatures would be that particular temperature probe is directly in the fluid. Here I've just attached a thermocouple to the outside of the stainless steel. But even through the thick wall of that stainless steel, you can see that even the end of this little makeshift thing is down to almost minus 36 degrees. So again, the first part of our demonstration is to show you its cooling capacity. We are not using thermal fluid. Normally the properties of thermal fluid that are typically used in a unit like this is that it can achieve very low and very high temperatures without either freezing or without boiling. For our particular part of this demonstration, we are using alcohol, IPA, very clean, brand new alcohol, and we're down to just about the lowest point we can go. So what we're going to do now is we're going to warm this back up, hit temperature, and I'm going to bring it back up to our room temperature, our ambient temperature of 20 degrees. And shortly the valves will shift and this will start heating up. Notice the refrigeration valves went off and now we will be heating up. As you can see, it is already starting to climb in temperature. There you go. So what I'm going to do now is get back to ambient temperature. Then I'm going to drain all the alcohol out of the system. And for our heat up part of our demonstration, I will just fill it with good, clean DI water. And we're going to heat it up to about 80 degrees C, which is 176 degrees Fahrenheit. Just to show you that it does heat up. And so we'll have you guys back in a little bit. Back now. I've completely drained the system and the hoses out of all alcohol, rinsed it out clean. We now have DI water in place. Before we start up, I just want to show you one feature down here that's very convenient. If you look down here, you'll see a drain plug. That drains the system. This is also a drain, and that's a drain as well. When you drain the system, I have found that especially with the thermal hoses, if you hang them up and you open this up, and then this is very convenient. This is a valve that you turn counterclockwise, and this will open the valve to this drain, so it, you know, when you have to stop, it doesn't fly all over the place. So that's something very convenient. I thought when we start up for this second part, we take you right from the power up sequence, so you can see the boot up as well. Now first we'll turn on the power. You'll hear a cooling fan go on, and then this actually turns on the controller. Now it'll go through a boot process along with self-diagnostics. First it'll turn on the circulator. And now that we're going to heat it up, the refrigeration will come on. What we'll do is we'll change the temperature for this part of our demonstration to plus 80 degrees C, which is the equivalent of 176 degrees Fahrenheit. And now we'll heat up the system. We'll come back in a little bit and see how it's doing. Okay, we've now come up to about 80 degrees C. This again is testing with water. We're measuring here at right at the end where your cold trap or your application would be, and it's measuring through the thick stainless steel wall, and that's about 1.3 degrees difference, so that's pretty good. Other than that, once you read the manual, you'll find this is very easy to set up in automatic or manual, and it's very reliable and extremely precise. This completes this demonstration.